Hello student, welcome to the Ria2 YouTube channels. Today we are going to study the topic of integrations. Before we start the integration, please I request you subscribe my channels. If you like my channels, please share and like also. Today we are going to study the integrations. Integration means what? We hear this definition. The definition is that the derivative if we take the derivative of this f of x, we get g of x. If you take the derivative of f of x, we get a g of x. Then f of x is the integral of g of x with respect to x. Means if you take the integration of g of x, we get the value of f of x. When before, if the derivative of f of x, we get the g of x, but we take the integration of g of x, we get the f of x. Means that integration means the reverse process of derivation. Integration means the reverse process of derivation. It's called as the anti-derivatives. We take this here example, integration of this f of x, integration of g of x with respect to x, we get value what? F of x. Means that f of x plus c. But if you take this derivative of this f of x plus c, we get value of g of x. Means that the integrations and derivatives are to connect to each other. Reverse process. It's called as a reverse process means if you find the integrations, means that it is the anti-derivatives. Okay, if you see that the f of x is called as the anti-derivative of g of x. F of x is called as a anti-derivative. It's a reverse process of derivative. It's of g of x. Okay, derivative. If you take this derivative of this f of x, one of this example here, if you take the derivative of this f of x, okay, f of x, we consider that the derivative of f x is equal to f dash x. But if you take the integration of this f dash x with respect to x, we get f of x plus c. F of x plus c, this is the values of integration. If you take this integration of f dash x, we get the f of x plus c. Understood? The integration means what? Integration means is a reverse process of the derivative. What is the application of integration? The application of integration is we have to find, by using the integration, we have to find the area under the curve. We have to find area under the curve by using the integration. We have to find the area bounded under the curve. We take this 2 point in under the curve. We have to find the area by using, we would define this area under this curve. Okay, this is the application of integrations. Now we discuss the standard formula of integrations. First is, if we take the derivative of this x raised to n plus 1 upon n plus 1 is equal to, we get the x raised to n values. But if we take integration of the x raised to n with respect to x, we get values of what is the value? We get x raised to n plus 1 upon x raised to n plus 1 upon n plus 1 plus c. If you the integration of x raised to n with respect to x, we get x raised to n plus 1 upon n plus 1 plus c. If you integration of this, the derivative of this log x is equal to 1 upon x. Okay, but its condition that x is greater than 0 is positive. What is this? If you derivative of the log x is equal to 1 upon x, if you take the integration of this 1 upon x with respect to x is equal to what? Log x plus c. This is value as 1 of x. If you take the integration of this with respect to x, 1 upon x is equal to log x plus c. If you integration of this cos x with respect to a, similarly, if you integration of this cos x with respect to a, if you integration this, what it is, cos x integration is what? Sin x plus c. If you integration of sin x with respect to x, we get this values of minus cos x plus c. If we integrations sec square x with respect to x, we get the values of tan x plus c. If we integration of cosec square x with respect to x, we get values of cot x, but this cot x is a minus value plus c. If you integration of sec x into tan x, we get values of what is a sec x plus c. We have the repeat again. If your derivative of the log x is equal, the derivative of log x is equal to 1 upon x, but if you take integration of 1 upon x, if you integration of 1 upon x, we get the log x plus c. If we the derivative of this sin x is equal to cos x, if you take the integration of the cos x with respect to x, we get the sin x plus c. If you take the derivative of this cos x is equal to value minus sin x, but if you take integration of sin x with respect to x, we get this minus cos x plus c. If you take the derivative of the tan x, we get the sec square x, but if you take the integration of the sec square x with respect to x, we get the tan x plus c. If we take the derivative of cot x, we get, you know, that the cos x square x, but if we take the integration of the cos x square x dx with respect to x, we get a minus cot x plus c. If we take the derivative of the sec x, we get the values of sec x into tan x, but if we take the integration of this sec x into tan x, we get the sec x plus c. This is a standard formula. Again, this some formulas. Okay, see here we know the derivatives. The derivative of this cos x, what is the derivative of this cos x is minus cos x plus cos x into tan x. So what is the integration of cos x into cot x? If you try to find the integration of this cos x into cot x is equal to, with respect to x, we get the values of minus cos x plus c. If you do the derivative of this, we know that the derivative of e raised to x is equal to e raised to x, but if you integration of e raised to x with respect to x, we get e raised to x plus c. If you try the derivative, you know that the derivative of a raised to x is equal to a raised to x into log a, but if you try the integration of this a raised to x with respect to x, we get a raised to x upon, what is this, log a raised to x upon log a plus c. Okay, now if you try there, next is the sine inverse. We know the derivative of sine inverse x is equal to 1 upon under square root is under square root 1 minus x square. If you try the integration of this 1 upon under square root 1 minus x square with respect to x, we get values of sine inverse x plus c. If you try this value of integration minus 1, we try the integration of minus 1 upon root 1 minus x square with respect to x, we get this value what? Cos inverse x plus c. If you try the integration of 1 upon 1 plus x square with respect to x, we get what? Tan inverse x plus c. If you try the integration, if you try the find integration of minus 1 upon 1 plus x square with respect to x, we get value is minus, no, not minus, this plus, this is just minus 1, minus, so this we get cot inverse x plus c. Okay, similarly, if you try the integration of 1 upon what? X under square root x square minus 1 with respect to x, we get values what? Sec inverse x plus c. Okay, similarly we get the integration of this minus 1 upon root upon x into x square minus 1, we get this value is a cosec inverse x. Cosec inverse x. Again I repeat, okay, if you try the derivative of this cosec x is equal to cos minus cosec into cot x, but if you try the integration of this cosec into cot x with respect to x, we get this minus cosec plus c. If you try the derivative of e raised to x, we know that the derivative of e raised to x is e raised to x, but if we try the integration of e raised to x with respect to x, we get values of e raised to x, again e raised to x plus c. If you try the a raised to x, derivative of a raised to x, we know that a raised to x into log a, but we derivative of this integration of this a raised to x, we get with respect to x, we get a raised to x upon log a plus c. If you try the derivative of the sine inverse x is equal to 1 upon root 1 minus x square, if you then try the integration of this 1 upon 1 plus x square with respect to x is equal to sine inverse x plus c. Similarly, integration of this minus 1 upon under square root 1 minus x square with respect to x is equal to cosec inverse x plus c. Similarly, integration of 1 upon 1 plus x square with respect to x is equal to tan inverse x plus c. Similarly, integration of this minus 1 upon 1 plus x square with respect to x is equal to what? The cot inverse x plus c. Similarly, if you try the integration of 1 upon x into square root under square root x square minus 1 with respect to x, we get a sec inverse x plus c. And then similarly if we try integration of minus 1 upon x under square root x square minus 1 with respect to x, we get values cosec inverse x plus c. This is the standard formulae of integration. We will solve the different problem on this basis of standard formulae. Now we have solved the examples. Integrate the following. First example is that the x raised to 4 plus x cube plus x plus 1 with respect to x. We have to find the integration of this function x raised to 4 plus x cube plus x plus 1. Now solution, if you try the integration what? X raised to 4 plus x cube plus x plus 1 with respect to x, what we get? This integration applied to this x raised to 4, we get integration x raised to 4 with respect to x plus integration applied to x cube with respect to x plus integration x with respect to x. Again this 1 is a constant value, integration of this 1 with respect to x. We know that's the standard formula we have to discuss now. The integration of x raised to n with respect to x, we get the x raised to n plus 1 upon n plus 1 plus c. We have to use this standard formula. We get this value, the x raised to 4. X raised to 4 we get x raised to 4 is what? X raised to 4 plus 1 upon 4 plus 1. We get this again the value is x raised to 3 plus 1 upon the 3 plus 1. Again the x raised to this is x raised to 1. X raised to 1 means what? X raised to 1 plus 1 upon 1 plus 1. This integration of this one what? X plus c. And now what is the values of x raised to 4 plus 1 is what? 5. X raised to 5 upon this 5 plus x raised to 3 plus 1 4 upon this 4, and x raised to 1 plus 1 x square upon x raised to square x square upon 2. This is x plus c. This is the integration of this function. Now second example is that how to find the integration of x square 1 minus 2 upon x bracket squared with respect to x. So now see solution. How to find the integration of x square bracket 1 minus 2 upon x bracket square with respect to x. We had to find, firstly we had to expand these values. 1 minus 2 upon x bracket squared. We know the formulas. What is the formulas? A minus b bracket square. We get values what? A square minus 2ab plus b square. Okay, using this formula in this example, integration of x square. What is the expansion of this 1 minus 2 upon x bracket square? 1 square 1 minus 2 into 1 into 2 upon x. What is the 2 upon x square? This is 2 square 4 x square. This x square is x. What is the values of square of x? X square. And then with respect to x. And now this x square multiply this 1, we get x square this x square, this multiply this 2 4 into this. What is the 2 into 2 is 4 x square into 4 upon x. This x square into 4 upon x square with respect to x. This apply this values, integration of this x square with respect to x, and then this x square cancel, this x term cancel, we get this integration of this 4 is a constant taking the behind the integration, and the 4 what is the value? Get this x with respect to x. This x square is cancelled. What is the value? This 4 integration of this what? X. What is the values of integration? X square is the x square. X square is what? X cube upon 3, and this minus 4 x. What is the integration of x square? This is 1 x square. This x square upon 2 plus this is x. This 1. What is the integration of 1? X. 4x. We get the 4x plus this 2 1s are 2 2 2 are 4. We get value x cube upon 3 minus 2x square plus 4x plus c. Now the third example is that what is the example? See, we have to find the integration of what? Sin 2x upon cos x with respect to x. How to find? We know this, I think that we know the trigonometric formula of sin 2x. We get values of 2 sin x into cos x. Use this formula, and using this formula we find this integration. What is sin 2x? Sin 2x is a 2 sin x into cos x upon what is this? Cos x with respect to x. This cos x cancel. This 2 is a constant value. Take out of this integrations the 2. This sin x with respect to x. What is integration of sin x? What is integration of sin x? This minus 2 cos x plus c. This is the integration of this function. Okay, these three examples now we have to discuss. Next example we have take more example to solve the example. Okay, we have to take more example. We will going to solve. Thank you very much watching my videos. Please, if you like my videos, please share, subscribe my channels. Thank you very much.